Hello everyone, good morning. So today is our lesson 6, right? So have you completed your homework already? Which is page 59 to 60, question number 13 and 14. Okay, this will be our last part for this topic. Okay, I hope you have done question 13 and 14. I'm not going to explain in detail. And this is our working for question number 13. Right, so we are solving quadratic equations with word problem. Right, so the answer for question 13 is $20. Okay, please check your answer and the working. And for question 14, the answer is 52.3 km per hour. Right, so this is the solution and the working. Okay, you can go through this by pausing the video and check the solution if your answer is not correct. And if it's correct, please tick using a red pen for these two questions. Okay, and if you have any question, you can always text me and ask me question. Alright, so that's it for chapter 2. We have completed our chapter 2, so we have to continue to our chapter 3, which is function notations. Okay, so textbook is page 66 onwards. Okay, page 66 onwards on function notation. Okay, alright, so let me explain on give you a bit of brief of function notations. Okay, alright, so function is a relation, from input to exactly one output. Okay, let me illustrate this function. Okay, so this is a box. Okay, let this be a box and it's a machine. Okay, and this machine is an input and output. Okay, so this is input and this is output. Okay, so let's say we are going to put a number in. Let's say it's 2. Okay, so then we put it through the input, and the machine generate the output and gives you a 4, let's say. And if you put in a number which is, for example, 3, and the output, it will gives you a 6 after generate in the machine. Alright, and if let's say you are putting in a 8, okay, and it will generate and gives you an output which is 16. Okay, so we know that this machine, it generates an input and gives you an output, right? And we know that this generate a function which is times 2, right? 2 times 2, it gives you a 4. 3 times 2, it gives you a 6. 8 times 2, it gives you a 16, right? This machine, we call it as function. Okay, this machine generate a function. Okay, and we have to it has to be written in a simple way. Alright, so we write this in this form: f 2x is equals to 2x. Okay, for this machine, okay, we can write in a simple way as a function as f of x. Okay, we read this as f of x is equal to 2x. Okay, f of x is 2x. Or it can be written in this form: f dot x with the arrow 2x, which is basically is the same thing as f of x is 2x. Alright, okay, so f of x is 2x. It's basically meaning x here is your input and your 2x here is your output. Okay, so we can actually write as when x is 2, your function f will be equals to 2 times 2 which is 4, right? And when x is 3, your f will generate a 2 times 3, which gives you a 6. And when x is equals to 8, your function will give you a 2 times 8, which is a 16. So in this case, instead of writing when x equals to 2, when x equals to 3, when x equals to 8, it is much more simple to write in this form. F, when you put in 2, it will give you a 4. When x is 3, it will give you a 6. When x is 8, it will give you a 16. Okay, it's much more simple to do it, isn't it? Okay, so instead of writing when x equals to 2, when x equals to 3, when x equals to 8, we write our function as f of 2 is 4, f of 3 is 6, f of 8 is 16. That is only when your function is 2x. Alright, so most of the time we write as y equals to 2x. This is also a function, right? This is also a function, right? And it's just that when we write when x equals to 2 and y will be equals to 4, when x equals to 3 and y will equals to 6, and when x equals to 8, then y equals to 16. Okay, so it's quite a hassle to write this long phrase when x equals 2, y equals 4, when x equals to 3, y equals to 6. Why don't we just write this term in this type of equation, right? So f of 2 is 4, f of 3 is 6, f of 8 is 16. Okay, it's much simple to write in that way. Alright, okay, so we call it function when we have one input and gives you one output, right? Or we can have multiple inputs and we have only one output. Okay, I give you another example. Okay, this machine, this is a function now, and we have a function now, let it be x squared, right? Let it be x squared. So we have an input, let's say we have an input of 2. Okay, and after it generates the function, it will give you an output which is 2 squared, which gives you a 4. 2 squared is 4. And if it's a negative 2, okay, and when x is negative 2, your output will be also 4, because negative 2, when you square it, it will become a positive 4. It's the same output, alright? It's the same output. Meaning to say that we have multiple input here. We have multiple input and it gives you only one output, which is the same output, which is 4. And this one is also called a function. Okay, we call this as function as well. So we go back to the definition of function. A function is a relation from input or inputs, it can be a lot of input, to exactly one output. And if we have only one output, and it's called function. Okay, so object. Now the second and third one is object and image. What does it mean by object? What does it mean by image? Okay, I'll simplify in this form, right? So object of 2, this is our 2 object, which is also an input of 2, it gives you an output of 4. So object of 2 map onto image 4. Okay, maybe I should write it down. I erase all this. Okay, please copy all this into your notebook. Alright, you write it in your notes that it's easier for you to understand when you refer back to your notebook. Okay, I will use the same example. F of x is 2x, alright? Okay, I will use this. So object 2 map onto image 4. Okay, and object 3, how about object 3 map onto image 6. Okay, you see that? Object 3 map onto image 6. And what object will map onto image 16? Can you answer me that? What object map onto image of 16? Yes, the answer is 8. Okay, because the image here is 16, the object here is 8. So object and image is the individual input and output. Object is for the input, image is for the output. Okay, again, object is individual of input. One input is considered as the object. So object of 2. Okay, object of 2 is under the input and image is under output. Right? Object of 2 map onto image of 4. Okay, so our object here is 2, 3, and 8. Okay, so basically your object is your X. Okay, which is your input. And as for your image, is your output. Okay, your image is your output, which often denoted as Y. Okay, your output is Y, or in this case is 2X. Okay, in this case your output is 2X. Image is your 2X. Okay, individual output. Right? Okay. For domain, okay, domain is basically I'm using the same example here. Your domain will be 2, 3, and 8. It's a set of input. Okay, it's a set of input, or it's a set of your X. It's called domain. Okay, which is 2, 3, and 8. Okay, as for range, it's a set of your images. Okay, it's a set of images which is 4, 6, and 16. Okay, so domain, we can denote that domain, okay, it means a set of objects or a set of your inputs. Okay, all these 2, 3, and 8 here is your objects, and which is called domain. Okay, and your images, which is 4, 6, and 16, is range. So range is a set of images. Okay, so I give you another example. Okay, so let's say we have a relation of fx which is equals to x squared. Okay, so object of 2 will map onto image 4. 2 squared is 4, by the way. Okay, f of 2 is equals to 2 squared, which is 4. Okay, the object of negative 2, after you square it, okay, it will goes to 4. So your output is 4. Object of negative 2 map onto image 4. Okay, and let's say you have 3. Object of 3 square will give you a 9. So object of 3 will map into 9. Map onto 9. Okay, so the domain here, which is a set of X or a set of your objects, can be written down as this way: 2, negative 2, and 3. And range is 4 and 9. Okay, so when the question asks you to find domain, this will be your answer. And if they're asking you to find range, this is your answer. Okay, and if the question say, okay, find the image of object 2. Okay, so if your object is 2, your image is 4. So the answer, find image of object 2. So the answer is 4. Okay, or find the object when the image is 9. Okay, so find the object when the image is 9. The answer is 3. Okay, so you have to understand what is object, what is image, and what is domain, and what is range. Okay, and also function. Imagine function is just like a machine here, which relate the input and also the output. Okay, so this machine is considered as a function. The function can be times 2, can be times 3, can be square, can be cube root, can be any expression. Alright, so object is input. Basically is input. Whatever object, whatever x that you put into the function, it will generate and give you an output. Okay, so object, image is basically your input and your output, right? And domain is a set of objects. Okay, it's a set of all the objects, it's a set of all the x. Okay, any input that you put in, the set of all the object is considered as your domain. And range is a set of your images. Alright, it's a set of your images. Okay, alright, so I have summarized all this already, the definition of function, object, image, domain, and range. Now we will go to the next one, which is type of relation. Okay, type of relation. Okay, we have 4 types of relation here. Okay, I will illustrate in these 4 arrow diagram. We call it arrow diagram. Okay, make it simple to make you understand the types of relation here. Okay, let's say, okay, the first type, we have object A, object B, object C. Okay, and we have an image of D, image E, image F. Okay, you know what is object and image already, right? So our A, object of A, let's say is map onto image D. Okay, we have an arrow here. And object of B map onto image of E. And object of C, okay, map onto image of F. Okay, this type of relation we can call it 1 to 1. Okay, one input to one output, right? We can know A, B to D, B, E, C, F. Okay, I give you an example. For example, a boy A. Okay, this is a boy A, a girl D. So boy A relationship with girl D, boy B relationship with girl E, and all this relation we call 1 to 1. So it's a relation of 1 to 1. Okay, so another type of relation, we can call it okay, I let you figure out what type of relation, okay, later. So object of A will map onto image D. Okay, and object of B goes to or map onto the same output, which is D, same image, which is D. Okay, and object of C, okay, will go to E, map onto E, and F, nothing. Okay, for image of F, there's no object for that. Okay, so we know that A and B in relation with D. Okay, A to B map onto the same D. Okay, this type of relation we call many to one. Okay, many to one. Okay, just like I say, if let's say A, B, C here is a boy. Okay, D, E, F here is girl. A and B goes to one girl. Okay, so it's like many relation to one, many boys to one girl. Okay, which is inappropriate basically, but then this type of relation we call it many to one. Okay, even though we have one C, one object C to one image of E, even though we have 1 to 1 here, but overall here we have many to 1 because of A and B maps to only one input or one image, which is D. Okay, so overall here we can see this kind of relation is called many to 1. Okay, I want to add on here. Okay, the domain is A, B, C. But for range, we only have D and E without the F, because F here, there's no object for the F. Okay, so the F here is basically display only, right? Display only. So we are not including F in our range. But F is still an image. But this image has no object, right? But range, only D and E, because in this diagram, only D and E are the outputs. Okay, all right. So we have two types of relation already. You can see 1 to 1 and many to 1. Okay. The next type of relation, okay, object of A will map onto D. An object of A will goes to E as well. Okay, and object of C, let's say, will go to F. Okay, so this type of relation, A to D, A to also E. So one input to many outputs. So this type of relation is 1 to many. Okay, 1 to many. So one input to many inputs, which is D to E. Even though our C here object, the image is F, only 1 to 1 here, but overall we can know that this relation overall in this arrow diagram is 1 to many because of the A gives to D and E. Okay. And this type of relation, it will look very messy. A to D, A to E, and this image of D can be coming from object of B, and this C here can also goes to D or even goes to F. Okay, so you can see one input can go to many output, or many input can go to one output. Okay, you see B to C here goes to one output D, and one input of A, object of A, goes to two output, which is two image DE. So this type of relation is very messy. It's called many to many. Is this actually called a function? No. Okay, so I cannot say function of K is many to many, because K is basically is not a function. Okay, H is also the same. We cannot say that H here is a function of H, because H is not a function. Okay, function is called function. Okay, it's only called function when it only has one output. Okay, function is called function when it has only one output. Okay, which is only one output. Okay, it can have many input but not many output. Okay, so these four types of relation. Okay, so H just now I cannot say it's a function. I can only say it's a relation, because we can see there's a relation between input and output. And K, we can say that it is also a relation. K is also a relation. Okay, because it has a relation between inputs and outputs here. Okay, but we cannot say H and K as function, because they are not function, because they have many outputs. Okay, so this is not function. H relation is not function. K relation is also not function. But F and G, the relation of F and G are called function, because both of these relation has one output. Okay, these relation are function. Okay, so functions are only for F and G, and not for h and k. Okay. Okay, so relation of f and g, which is one-to-one and many-to-one, are called function because they have only one output. Okay. H and k, the relation of h, the relation h and relation of k are not function because they have many outputs. Okay, they have outputs many. Okay, if one to many, many to many are not function, but one to one and many to one is called function. Okay, so I can summarize this. Function has only one output, which is the type of relation that is called function is only one to one and many to one. Okay, you see the one here. Okay, so function is only one to one and many to one. Okay, is that clear? Okay, I hope you can copy all this down into your notebook. Alright. Okay, this is type of relation. Now we will go to try it 1 and try it 2. Okay, so for today's lesson, it's only covered until try it 2. Yeah, so I've explained to you what is functions now, and the type of relation, and what type of relation are called function. And now we go to try it. Okay, let's look at try it 1 at page 69. Okay, which one of the following diagrams does not depict a function? Okay, let's look at the relation for all these A, B, C. Alright, the relation of A, F, G, H, function of F, G, and H, are they really called function? Okay, let's look at F in part A. Alright, part A. F. Okay, what type of relationship relationship between X and Y here? Okay, 7, object of 7 map onto 15, 5 onto 9, 2 onto 3. So this type of relation is called 1 to 1. Okay, and is it a function? Is function F can be called function F, or is just a relation F? Okay, so from what I say just now, type of relation, only 1 to 1 and many to 1 are relation, are called function. Okay, so 1 to 1 here is function. Okay, so this one, yes, it is a function. It is a function, yes. Function of F. Okay, it's called a function of F. Yes, it is. And B, what type of relation is this for B? Okay, you see 7 object goes to 15 image. Object of 5 goes to the same 15. Okay, and 5 goes to also 9. 5 goes to also 3. And input of 2 goes to also 3. Okay, so one input goes to many outputs, but on the same time, this one output here comes from 2 inputs, come from many inputs. So this type of relation we call many to many. Many function. So it's many to many relation. Many to many relation. So G is not function. Okay, because it's called many to many. It's the type of relation which is many to many, and it's not a function. G cannot be called a function because it's a many to many. Okay, how about C? Is this H called function H? Let's see. Object of 7 goes to image of 9. Object of 5 goes to image of 9 as well. And object of 2 goes to 9 as well. So we can know that these many inputs go to only one output. So it's called many to 1. So is this function H can be called function H, or is just a relation H? Yes, it's a function. Okay, it's a function of H because it has only one output. Okay, we go to the definition of function again. Function is called function when it only has one output. Okay, So these following diagrams here does not depict a function, is only b, and explain your answer. Okay, the explanation is already here because it's a many-to-many relation. Okay, right, that's for try it 1. Okay, try it 2. Two functions p and q are given as, okay, so p, you look at this, p dot dot x and then arrow x squared minus 3. This one we can actually write down as p of x is equals to x squared minus 3. Okay, you can write in this form. Both of these forms are the same, okay? And q dot dot x arrow x plus 2, this one can be written as q of x equals to x plus 2. Okay, if you don't like to be written down in this way, you can always change to what I've written just now. Okay, it's basically same thing. Okay, A, the domains of P and Q are, okay, so domain are your set of objects or set of inputs. Okay, so these are your inputs, -2, 2, 4, and 6. Find the range of P. So what is range again? Okay, go back again. What is range? Range is a set of your images. Okay, it's a set of your images or a set of your outputs. Okay, it's a set of your outputs. Okay, so you have inputs already. You have domains here, -2, 2, 4, 6. Okay, find the range of P. Okay, A, first part. Okay, we have function of P, which is x squared minus 3. Okay, this x squared here, minus 3. So find the range, find the output basically. So domain is already given, -2, 2, 4, and 6. So we sub it in. So when x is -2, when your object is -2, you sub it into the function, and we will get 4 minus 3, which is 1. And if we sub in 2 is in your input, and 2 squared minus 3 will gives you also 1. Okay, and when you sub in 4 into your x, which is your input is your x, 4 squared will gives you minus 3 equals to 13. Okay, and when you sub in 6 squared minus 3, it gives you 33. Okay, again, all these are your inputs. Okay, inputs, so your object of -2, object of 2, object of 4, object of 6. Okay, and then your outputs here, here 1, 1, 13, 33. All these are your outputs. Okay, which is also can be written as range. Okay, so range is a set of your outputs, right? So range here will be equals to 1. Okay, you don't need to write the same one again. You don't need to write 2 times. Okay, you only need to write only 1 time. So 1, you don't need to write the repeated one. Okay, 1, 13, and 33. Range. So this is your answer for your first part. The range of P is 1, 13, and 33. Okay, part 2. The range of Q. So your Q function is x plus 2, alright? So your domain is -2, 2, 4, and 6 as well. It's the same thing. So you sub in when it's a -2, it will give you 0. And if you sub in 2, it will give you 4. And if you sub in 4 into the expression, 4 plus 2, your output will be 6. And if you put your x, sub your x as a 6, okay, -2, 2, 4, 6 comes from the question, huh? Okay, then 6 plus 2 will be equals to 8. Okay, so all your outputs are already here, which is also your range. So your range of Q is 0, 4, 6, and 8. Okay, so this is your range. So far, okay? Okay, so far, alright, So you have to know the definition again of function, object, image, domain, and range. Okay, you need to understand the words here, the vocabulary of the 5 words just now. Okay, hope you don't confuse. Okay, part B. Hence, draw an arrow diagram. Okay, arrow diagram is like what I draw here, like this. These are called arrow diagram. Okay, arrow diagram. Okay, so we have domain, your input part, and your output part over here. Okay, and the mapping of P, the function of P. Okay, so this one, the function of P. Okay, function of P. So the object, all the objects, which is your domain, -2, 2, 4, and 6. Here, -2, 2, 4, and 6. Okay, your objects are always on the left side. And your images, which is your range, which is 1, 13, and 33. We can look at A first part, yeah? We can look at A first part. This is B first part, by the way, the arrow diagram of function P, right? Okay. So it's from here, -2, 2, 4, and 6, and -1, 13, and 33 here. So we can draw our arrow. Okay, -2 object, object of -2 maps onto 1. Object of 2 goes to 1. 4 goes to 13. 6 goes to 33. Okay, so this is the arrow diagram of function P. Okay, and part 2, we will draw an arrow diagram for function Q. Okay. Okay, we have the same input, -2, 2, 4, and 6. Okay, with the function Q now, which is x plus 2. Okay, and our image now is 0, 4, 6, and 8, which are your range. Okay, so this type of relation is -2 to 0, 2 to 4, 4 gives you a 6, 6 gives you a 8. Okay, and you can know that this type of relation, first part and second part, or which link to your part C. What types of functions are P and Q? Okay, so P, function of P is a many to one relation. Okay, it's a many to one function. It's a function because it has one output. Okay, because we have many inputs, which is -2 and 2 inputs, goes to only one output, right? So function of P is many to one, and function of Q is obviously 1 to 1. Okay, it's also called function because it has only one output. Alright, so we have finished our try it 2. That's all for today. I would like you to copy all this into your notebook and also do some questions from the textbook. We have done our try it 1. Okay, we've done our try it 1, and we have tried the try it 2. Okay, and let's do some exercises as your homework. You can try to do question 1, question 2, 3, and 4. I will discuss with you in next lesson. Alright, okay, hope you guys understand what is function now. Okay, hope you get the idea of what function is. Alright, so please try to do this page 72. This is page 72. Exercise 3.1, question number 1, 2, 3, and 4. Okay, that's all from me today. See you guys in next lesson. Bye.